Section 2.4 is titled Writing Linear Functions. We're going to go over a new form of a linear equation called Pointslope Form, which is almost exclusively going to be used to write linear equations. And then we're going to use linear functions to solve real-world problems as well. First example, just to introduce us to the idea of writing a linear equation, asks us to write the equation of the line shown in the graph below. Now think about a linear equation, slope-intercept form, y equals mx plus b. We need to know two things. We need to know the y-intercept and the slope. And sometimes in looking at a graph you can see exactly those two things that we need. Well, right here is the y-intercept. I can see for this line it's at -1. And if I look between 2 points, I can find the slope. I went up 2, right 3, so the slope for this line is 2/3. And so all I have to do, if I can see those from the graph, is just drop those in for the m and the b respectively. The equation of this line is 2/3 x minus 1. Now, finding the slope is oftentimes not as easy as it was in the last problem that I just did. Oftentimes you don't have a graph, and it might be a little tedious to take the time to actually draw a graph to find the slope. So I want to develop a way to find the slope when we don't have a graph. To get to that way, I'm going to look at a graph though. So let's say we take 2 points on this graph, and I want to find the slope between them. Okay, well I know that the slope, m, would be defined by this. Okay, if you haven't seen it before, the little triangle symbol means it's a delta, and it means change. Slope is the change in y divided by the change in x. So the question is, how do we compute that change? Let's label these points. I'm going to call this x1, y1, this x2, y2. We find the change in the y values by finding the difference in the y values, and the change in the x's by finding their difference. Okay, that's how we find slope. It is the subtraction of the y's divided by the subtraction of the x's. That difference computes the amount of change in each direction respectively. So this is how we're going to find slope when we're given 2 points. So an example of that asks us to find the slope between the points -2, -3, and 4, 0. My slope formula again, y2 minus y1 over x2 minus x1. It doesn't matter which one of these points is the x1, y1, which one's the x2, y2. You can label them however you want. You can subtract them however you want. So I'm going to do this y minus this y divided by, now here's the most important part, since I started with this y in the numerator, in the denominator I must start with this y's x. So 4 minus x, -2. The minus negatives become pluses, so we get 3 over 6. So the slope between these points is 1/2. Alright, I want to go over one more form of the equation of a line. It's called point-slope form. It's probably the most useful formula in dealing with linear equations, or at least as far as writing linear equations go. It is this. It is y minus y1 equals m times the quantity x minus x1, where the slope is m, obviously, and the point is x1, y1. So you're going to be substituting numbers in for the slope and the point. The other x and the y will stay as variables x and y in the equation. We will not replace those with numbers. Alright, let's do some example problems using point-slope form of a line. Directions say to write the equation of the line given that the slope is 3/2 and it passes through the point -3, 4. So let's write point slope. The point, the x value of the point goes here, y value goes there, the slope 3/2 goes here. So let's plug those in and then we're going to be off and running from there. So it's going to be y minus 4 equals 3/2 the quantity x minus -3. Change that to plus 3. We're going to distribute the 3/2. So y minus 4 equals 3/2 x plus 3/2 times 3 is 9/2. I'm going to add 4 to both sides. So we get y equals 3/2 x plus 9/2 plus 4. 4 is the same as 8/2. 8 divided by 2 would be 4, so that allows me to add these fractions together. I'd have 17/2. Next example, we're asked to write the equation of a line given 2 points. So I'm going to need to use point slope. What's lacking here is the slope. I was not given the slope, yet I'm going to need the slope to do this problem. So that's the first thing I need to do, is I need to find the slope. I find the slope by doing y minus y divided by x minus x. So there's my slope, -3/2. Okay, so now we need to plug in to this equation. The slope, -3/2, go in there. I can pick either of these points to be the x1, y1. It doesn't matter. Let's just call this one the point that I use. But I can use either point again, and it won't make a difference which one I do. So I'd have y minus 4 equals -3/2 x plus 1. I'm going to distribute the -3/2. So y minus 4 equals -3/2 x minus 3/2. I'm going to add 4 to both sides. Finishing the problem, I have y equals -3/2 x. Again, we saw in the last problem this 4 can be thought of as 8/2 to be able to add together. Makes positive 5/2. Next example is just like the last one. If you want, this would be a good opportunity to pause the video and see if you can do this one on your own, and then just fast forward to check the answer. If you want, you can watch and I will work the problem out for you as well. So however you like. So I begin by needing to find the slope. I need to find the m. So we do y minus y over x minus x gives me a slope of 5/1. So m is just 5. Okay, now I'm going to use point slope. Okay, and I am going to choose this point And obviously the slope are going in for these three spots respectively. So we have y minus the y equals mx minus the x. I will distribute the 5. Give me y minus 3 equals 5x plus 25. Add the 3 to both sides. And so we finish with y equals 5x plus 28.